So now that we have learned about batteries, I would like us to perform a lab here to answer a question. So I have some elements here. I have some copper, I have some zinc, and I'm trying to put them in a random order so I'm not just giving away an answer here. I have some aluminum, I have some iron, I have some lead, and I also have, and I'm going to try not to use the word element, or metal, but element, I have some carbon here. Just to illustrate the point that it doesn't have to be a metal that's serving as an electrode. So I have 1, 2, 3, 4, 5, 6 elements here. And here is my brand new lemon. Now, this doesn't always work unless you roll up this lemon. You're kind of mashing all those little cells together to make sure the juices are kind of connected, which will allow charge to flow here. Okay, and when the juices are squirting out over my table, I've also kind of cleaned and sanitized it today, which is the added bonus. So I'm gonna try and answer a question here. Which combination of these 6 elements will produce the highest voltage? Now, you could look on the standard reduction potential chart, and you could just have the answer of theoretically what should create the highest voltage, but I want to know in reality what does right now in this silly little lemon. So we're going to combine all 6 of these with each other. It doesn't sound as bad as it isn't as bad as it might sound. And I'll give you a data table to help you organize the information because we're at the end of the year here. So I'm going to start out by just getting my first metal, lead, and I'm going to create a nice little hole here for it, and I'll put all the metals probably in the same little hole. I'm going to put the lead in there, and then I'm going to put my copper in here. And I kind of want to make sure these 2 metals aren't touching, but that they are in there. Okay, that's probably pretty good. So I got lead and copper, and now I'm going to connect these 2 metals with my voltmeter. And what am I getting here? Okay, my voltmeter set a negative value. So what that tells me is I have my wires connected to the wrong side. So I'm just going to switch my wires, and I got a maximum of, let's kind of mush this around a little bit more. So this might be hard to see, but I got a 0.4. 0.41 was the highest there on the voltmeter. Let me see if this will work better. 0.41. Okay, now let's leave the lead in there, save us some time, and now let's stick the aluminum in here. So the aluminum, I'm getting negative. Let's switch them. So the aluminum and lead is getting a voltage of 0.08. Take the aluminum out. I'm going to kind of keep these in order. I'll show you why later. Next, I'm going to put in my zinc, and my zinc and my lead are getting a voltage of 0.46. What about lead and Fe iron? This whopping massive 0.0. It was 0.02 for a second there. It doesn't matter. That one's terrible anyways. Okay, now this silly piece of carbon. Like, carbon can be an electrode? Yeah, carbon can be an electrode. Okay, that was a negative value, so I switch my leads, and I get 0.64 was the highest. Okay, now I've tested with lead with everything. I'm going to get lead and just toss it to the side, and now I'm going to get that second one that I put with the lead, copper, and now I'll go through and test everything with copper. So kind of methodically we'll go through each combination. So let's stick some aluminum in there. That's negative. I switch my leads, and I get 0.49 volts. Now let's do copper with zinc. Technically, you don't even have to switch the leads. You could just turn your negative into a positive. That should be what happens. We get 0.89 there. Now we're going to do copper with iron, and I get 0.43. And now I put the copper with the carbon, and I get a 0.21. Okay, we're done with our copper. We've tested everything with copper and lead now. So let's stick my aluminum in the first little. Hey, what do you think about lab error? Does the fact that we're mashing up this lemon differently between every trial probably change some things? Like, yeah, probably. Okay, let's put the zinc in the second one. Do you think I'm putting these metals in the exact same location every time I'm sticking them in? Probably not. That could be lab error too. There you go. Okay, aluminum and zinc, 0.38, 0.39 is my highest. Now let's do aluminum and iron. I got 0.07. And then lastly, aluminum and carbon. Got 0.71, 0.72 it went up to. We've now tested aluminum with everything, so we can get rid of that. Let's put the zinc in this left side. Remember, we don't know which one of these is the anode or the cathode until we really look at that standard reduction potential chart. It doesn't mean like the anode or cathode has to be in the left or right side here. Okay, so we're going to do zinc with iron now. I got 0.43 volts. We're going to do zinc with carbon. We got 1.08 volts here. .09 it went up to. And then zinc and iron here we have 0.44. Okay, so technically for this lab I wanted to find out which combination of metals. So I want you to like not use the carbon data for this because carbon's not on that standard reduction potential sheet. So the purpose of the lab will be able to solve which combination of these 1, 2, 3, 4, 5 metals cause the highest voltage. But I just wanted to show you how non-metals could maybe be used as electrodes also. So which combination of these 5 metals will produce the highest voltage in reality in this lemon right now? And then during this BEST trial, which element was the anode and which element was the cathode? So this will be our last lab report of the year. I'd encourage you to work in groups just to practice collaboration, but also less time for you. And I'll give you that sample data table to help you organize your data. Okay. Let me know if you have any questions.